Hey guys, my name is Jasper and I'm going to walk you guys through a limit problem. For those of you who are unfamiliar with the concept of a limit, I'll draw you a quick graph right here to summarize it. Now let's pretend this is our function. Alright, so this is f of x. Okay, and a limit is basically a point on the graph where a point on the x-axis where the actual function approaches. So let's say we wanted to calculate the limit at 3. We look at this point and see where exactly f of x is approaching when x equals 3. So at this point, it'd be 3, because f of x at point 3 equals 3 from both the right side and the left side. What that's saying is that as you get infinitely closer on that side and you get infinitely closer on this side, the f of x from your right and your left both converge to give you both converge to the point of 3 on your x-axis. And that point doesn't always have to exist for there to be a limit, because it doesn't matter how close you get. As long as you're not actually on the point, there can be a limit there. So we can draw an open circle here, which means there's nothing in the middle, which means the function is not continuous, but it's still a limit because you can get as close as you want to 3 on both sides without actually touching it. And this point right here is a removable point of discontinuity. Alright, so with that information in mind, we're going to go ahead and solve this problem. When you're first given a limit problem, what you're going to want to do is plug in your value for x, or what your x is approaching, into your x values in the actual function. So when we try that though, we get 3 minus 3 on the bottom, which is an indeterminate form. If you ever have some number, I guess constant over 0, you have an indeterminate form, and that we can't do anything with that. So we're going to want to simplify this and basically rewrite it so it's still the same function. So we're going to factor the top, it's x minus 3, x minus 3 all over x goes to 3. All right, so you're going to want to cancel either these two out of these two, doesn't matter, equivalents, and keep on going with your problem. Because now the bottom is out, and we won't have an indeterminate form when we plug in 3 for the limit. So now we have the limit as x goes to 3. X minus 3. We plug in 3 for our x. So 3 minus 3 equals 0. So in this equation we have, as the limit, or as x approaches 3, our limit is 0. What would that look like on a graph? There'd be a removable point of discontinuity right there. So here's our function. As x approaches 3, our y value, or our f of x, or our limit is going to be 0. And that's basically it. Thanks.